Check. Cool. Kind of nice having a talk in a movie theater. You get to do cool things like that. So anyways, I'm Todd Fisher. I want to talk today about moving fast as a software engineer. I want to give you kind of some context to start out with. So I currently work at a place called Philo Ventures. We are a startup studio. About every 2 months, we make a new startup. And so part of my role is to figure out who those founding engineers are, as well as in some cases actually build the actual product and get all the technical stuff kind of up and running. So we're typically constantly hiring for that type of role, the founder role type of thing. But one of the big things in my work is this idea of like figuring out how to like get things moving a lot faster, with templates or with other kind of practices out there. And so I've been really kind of heavy thinking in on this thought of like, how do we get this startup going as fast as possible and avoid a bunch of kind of the dumb technical things that come with some of the new code bases out there. So that said, I also want to encourage everyone to go to that utah.js.vercel app. And there's a couple of questions on there. That's more just to help kind of the whole audience. We're going to review some of those pretty soon here and just kind of share your thoughts on this topic. So awesome. So when I think about engineering, I think, even though socially sometimes as an engineer, I like to be all alone. I am my own island. But that's typically not the case. There's a lot of other things out there that affect how fast I can move, namely people, I guess. But typically, I think of the team processes that we're going through, that we're applying in our work, and of course, our individual contributors, or individual contributions as engineers, and other engineers as well. So with that said, I want to just kind of talk about some of these things in the next few minutes here. I want to start out with this fun little thing. Has anyone ever had to work towards a deadline? Boom, I think all of us have. And so there's always this interesting thing of like, hey, I know, Todd, you said it'll take 4 months, but we need it like in 1 week. And it's like, okay, so what do you do, right? And ultimately, a big kind of thing, a big lever, I would say, that I've used is scoping. You want to descope that thing down to the very minimal thing you want to that's functional out there. And so there's kind of this inherent kind of balance of like how fast you could deliver something with scope and as well as quality out there. And of course, in some cases, we deliver really fast and realize it's not very good quality-wise, and so bad things happen. So don't want to get into that, just want to kind of touch upon that a little bit. So I'm a big fan of descoping. I have been called the scope police in my career a few times. Typically, I just like to get down to the bare bones of what we need there. And so a few kind of tips that I've learned over the years is focus on the problem you're trying to solve. That's a big thing. A lot of times as engineers, we build this cool thing. Like, for example, I remember building like a dashboard for an executive years ago. And I took like 2 months on it. And then I showed it to him. He's like, can you just like email it to me? And I was like, what the heck, dude? So anyways, yeah, there's a lot of learning kind of in your career as you go and build stuff and you realize people aren't going to use it. So very much figure out what the problem you're solving on. Breaking things down into smaller pieces, there's always a lot of value in there. And as you break stuff down, really just understanding which of those pieces are more important. Oftentimes, there's a lot of subtasks that you probably don't need. So ideally, you want to focus on the ones that are most valuable first. And then at some point, you're able to kind of reevaluate and be like, do we need to do these other 5 tasks? Sometimes the answer is yes, but sometimes the answer is no. So you could just move on to the next thing, and that's pretty awesome, right? And this, of course, applies to kind of your bigger epics, if you will, as well as like I took a task from my work log, maybe I'm using Jira or Linear, and I could actually break that task down into smaller tasks and figure out, do we really need to like have this animation or whatever it may be? There's a number of things you could kind of descope there. So awesome. So let's go to the poll here. So hopefully everyone went to that QR code. Let's see what we got here. So the question is, as a software engineer, what slows us down? So thank you everyone for sharing. So YouTube, that's a big one. Yeah, I've slowed down before with that. Poor specs, yep. People, so people's in there. Bugs, there are a lot of bugs in here. Fingers, not sure what that one is, but that's cool. So pretty sweet. Thank you for sharing. So yeah, a lot of things slow us down as software engineers. Let me just kind of go back into that one again. And really like part of this, the intention of this talk is just to share and ideate on things that maybe could help us. So I wanted to call out with the problem here first of these things are effectively problems in some degree, some more severe than others. And so as we go through this talk, think about like maybe there's some other issues that you're dealing with at your work currently that's really slowing you down. So that said, Very big fan of this book called Accelerate. If you have not read this book, I encourage you to read this book. Pretty awesome. This is where the DORA metrics come from, which is how fast you can deploy, how long it takes to deploy, how long does it take to roll back, as well as how much bugs you kind of push out there. Those are considered the DORA metrics out there. But very awesome book. Beyond the 4 metrics, probably more favorite in my mind is they have a number of key capabilities for organizations. And so oftentimes with teams that I'm on, I like to go through kind of this exercise and self-evaluate, like which of these things am I doing well? Which of these things can we improve on? Let's talk as a team. It doesn't mean we have to like apply all of these things blindly, but more these are good talking points to figure out like, are there ways we could optimize, ways we could go faster, that type of thing. So awesome. And then I assume everyone here at some point in your life felt like there was someone you're working with that had no idea what you do on a day-to-day basis. Anyone? Raise their hands. So a few people, sweet, awesome. So very much have felt that in my career of like, I don't know what programmers do. Todd magically do random things, and that's always fun, right? But one thing I like to do as well is kind of take inventory of all the things I do. So this is typically what most software engineers do on a weekly basis. I like to go through this process of figuring out, okay, cool. I spend X number of minutes writing specs, or I read Slack a lot. Maybe I should do less of reading Slack, or do less of estimates or whatever it may be. Waiting for PRs is kind of a big one. But take inventory of what you do on a day-to-day basis. Maybe map out your process and figure out which of these parts are slowing you down. And oftentimes it's very obvious. Other times it's maybe not as obvious. So with that said, ideally in the customer value flow, we interview customers. We interview customers, and they basically say, we want X, Y, and Z feature, and that's great. And you could either go and blindly apply that, but oftentimes it's actually kind of a mask for what they really need. So it's very important as product people and engineers alike to basically figure out what they actually need in those conversations. And ideally, you go from what they say they want to what they need to actually building the thing that solves whatever they need, right? Awesome. So another fun thing that I've learned in my career is sometimes we move in the wrong direction and we're like, oh crap, like that was a big waste of time. So a few things that at least have helped me to figure that out. I'm going to share here pretty soon, but I think of recently there's a lot of talk around like AI is going to go and replace everyone and all that fun stuff. And one of the kind of arguments against that is this idea that code is not typically the bottleneck. It is alignment, aka people, I guess is probably another way to phrase that. So with that said, a couple of things that help create alignment here is making sure everyone understands what's going on your work board, on your work log, maybe you're in linear or whatever, and making sure that flow of work is visible. Maybe you're doing some Kanban stuff, and it's very easy to kind of see the progress you're being made, and more importantly, anything that's getting blocked, among other things. So also collaboration, very big to just talk to people. Oftentimes as engineers, we're just heads down and we're just like, okay, I'm just going to code this out. But every now and then, it's probably good to kind of take a breath from your deep work there and actually talk and check in and figure out, are we still on the right direction? Are we still aligned? I feel like oftentimes it's very easy to get misaligned because we just misunderstand each other. So that's a big one. Also, customer feedback, kind of touched on here. But really, customer feedback should be driving a majority of what we are trying to build, with some exception, of course. And healthy debate's another big thing there. There's typically more than one way to solve problems, so let's debate it out. Let's just not blindly follow the specs. Let's actually ask questions. Let's pick the specs apart. Let's figure out like if this is actually a really good solution, or maybe if there's a better solution, or what are the trade-offs involved between the two solutions, right? One thing that I love to do is within each of our tasks is to identify what value we're actually trying to deliver in our task. So it's like, hey, because oftentimes the engineers, it's like we have this cool product that we're building. I'm down here 10 levels deep in the org structure, and I'm building this cool stuff, but I don't really understand what the actual impact is for the business. That really sucks. So if we could have some degree of mapping that value down to what we're doing, I think at least for me as an engineer, that helps me to kind of understand better how I should implement things. So awesome. Another awesome quote that I love, code is a liability. And to kind of illustrate that point, raise of hands here. Ready? Have you ever spent more than a day updating dependencies? Boom. Have you ever been afraid to make changes to an old code base? Boom. Have you been slowed down by existing code when you added a new feature? Boom! Have you ever been confused debugging someone else's code? Boom. Have you ever been confused debugging your own code? Boom. That's probably a big one for me. Anyways, have you ever had scaling issues you had to address? Yes, right? Have you had code or features that were no longer being used? They're just kind of like sit on the side. There's like nobody like really using it anymore, and there's a debate of like, should I delete this or not, right? And of course, have you ever had to drop everything and fix a production issue? I feel like probably most of us in this room had to do that to some degree, right? So all this stuff is really related to like code is a liability, and an important thing to consider here is the code itself is not really what's important. It's the value that that code provides. Focus on that value, and then ideally, as you focus on that value, you realize you don't need a lot of these extra things, because the more code you have, the harder it is to maintain, and you run into a lot of these things more often, right? So with that said, there are estimates out there that us as engineers spend up to 50% of our time debugging. I feel like that's, depending on the week, that's probably pretty accurate, at least for me. And so there's kind of this inherent like question of like, can we like put that number down to where we're focusing on actual valuable things that we're trying to solve for, right? So with that said, given that less code is one enabler to move fast, here are some ways that we could kind of promote less code in our systems. Very first thing is say no to things. Like there's going to be times where someone comes to you and you're just like, yeah, I'll do whatever you want, that's cool. But oftentimes as engineers, we kind of just go and over-architect and build a bunch of bells and whistles we don't need. It's good to just have a little bit of pushback and be like, hey, actually, is this good? Like ask some questions, that type of thing, right? That helps a lot. Sometimes not writing code is actually the answer. So that's also another topic of a conversation that really helps us to focus on the things that we really need to be building as engineers there. Iteration, that's a big thing. I always like to iterate small pieces at a time and then figure out at some point, can we pivot? You aren't going to need this. And of course, build versus buy, that's kind of a fun one. There's oftentimes as engineers, we want to build really cool things. And it's like, I don't want to pay $20 for this service. That's a lot, $20 a month. But then you realize, wait a minute, it takes like, let's just say it takes 20 hours to build this thing ourselves, and then another few hours a month to maintain it. Then you actually realize it's actually cheaper in some cases to actually buy the thing, right? So another kind of fun debate there. Awesome. Very big believer of maintainable code bases, and very big believer that they help us to go faster. So kind of a few things here. Making sure naming things good, making sure there's some degree of documentation where if somebody comes and picks up the code base, or even if you come back a few months later, you're able to kind of understand what's going on. Making sure that you have kind of the right cohesion and loose coupling in how you structure your code. Linting, of course, another good one. Testing. Making sure that when you open your code base, it's very easy to understand what's going on in the code base. Another big thing there. Abstraction is your friend. At least a lot of times, it's also your enemy in other cases. But so really just make sure you're using abstraction in a good way. And of course, simplifying thing. One of the big things is complexity. Complexity is very easy to get really big. And so I think that we need to have a kind of this active like mental model of like, how do we reduce the amount of complexity in the systems we're building, and that could go a long way because there's a lot of bad code out there because we just let complexity run amok. And of course, refactoring, another good thing there. So, and it turns out all this stuff is applicable to if anyone uses kind of the vibe coding AI tools these days. It all helps regardless of if it's an AI doing stuff or if it's actually a human being doing things. So very much maintainable code bases is going to make you faster. All right. So in my research of like trying to figure out how to move fast as we start new projects, new greenfield projects, I think of like the no-code solutions. They have some benefits out there, but of course some trade-offs, namely customizability. I ran across this idea or this project called WASP, which effectively what they do is they have like a layer of abstraction on top of your React and Node stack, and you're able to effectively just add a bunch of JSON to kind of structure your app. It seemed kind of a cool thing. We actually went kind of beyond that because of various reasons, but won't get into that here. But kind of moving forward as we evolve into that kind of this AI, I guess, centric way of engineering. Want to kind of just talk briefly about this idea of the hype cycle that's out there. We all have heard the big hype of AI will do all the things, yada, yada. I feel like more and more we're more in this trough of disillusionment, which is great. That's kind of a sigh of relief because ultimately we get to this plateau productivity where we understand what it's good at, what it's not at. I feel like a lot of us are already kind of nearing that plateau. Some of us not so much. But I want to think through that a little bit here And Stack Overflow just released their latest survey about a few weeks ago, whenever that was. Apparently we have an increased rise in people using AI for programming, about 8% increase from last year. But also we see that more people are not trusting the accuracy of AI, which I think is a valid concern, right? Also, AI has decreased some positive sentiment. We're realizing what it's not good at, which is a great thing. And of course, we're frustrated with AI. I feel like in the last 2 years for me, when I've been programming, the majority of my debugging has been AI stuff that I'm trying to make right. I'm sure some of us probably have that same feeling in there. So very much, that is kind of the current state of things. But on the flip side, if we do lose all of our jobs with AI, we at least have kind of this backup plan of we could go and clean up all of the AI slop that people are generating via the vibe coding cleaning up specialist job. So that is an option for some of us. So awesome. So the big question that comes up is how can we overcome the AI slop? I don't feel like there's a one answer rule them all, but at least some thoughts here. So I use Cursor often. MDC files are a great way to kind of guardrail or guide how the AI generates code. Pretty useful, at least from what I've seen there, as far as making it better. Not perfect, but better. But some other things is making sure you're very focused on what you're trying to accomplish with the AI. It's less like, hey, AI, build me a Twitter clone, and more like, hey, AI, I want to add a payment processing button or some more specific thing. And even that, maybe that's too broad. You want to break it down into smaller pieces and iterate. And that typically allows you to pivot whenever the AI starts to go off the rails. So a very good thing there that I've seen, at least. Be more verbose than you think you should be. Be very explicit on calling out exactly what you want. And of course, I always press the stop button on a daily basis multiple times because I'm like, wait a minute, I didn't instruct it very good. Stop that, let's go do this, let's change it, that type of thing, right? And of course, context is a big thing. I do enjoy that Cursor has the ability to add files and other pieces of context because I think that helps a lot with making sure, following standards among other things. So, also a big fan of asking the AI, hey, what are 3 different ways to solve this bug, let's say, that we're working through? And oftentimes I ask, okay, there's 3 ways. Which is probably the one you would prefer and why? You could read through that, and there's kind of some nice kind of conversation going back and forth in there, which kind of brings me to the next idea of I really feel like AI coding assistants are kind of this paired programmer person. Granted, they don't have any hobbies or whatever, but they ultimately have this other kind of brain, if you will, to bounce ideas off of, to maybe introduce other ideas that you weren't thinking of. So very much beneficial in that regard. And also, learning new things. For example, Tailwind. A few months ago, I started using Tailwind, and it was nice to just ask the AI, what does this mean in Tailwind? And sure enough, there was a bunch of cool things that I learned because I asked them questions, right? So with that said, probably has it been a month or 2 ago, Amazon released another clone of VS Code, which we need more of those in the world. But anyways, their clone is called Kiro. And one thing that kind of struck me is that's really cool, is Kiro effectively guides you to focus on building out the requirements first. So you have a PRD effectively, and then also a design doc and a task list. And kind of a nice feature is they put all the stuff in a markdown file, and you could press this button right here to start that specific task and go down the list, and you could alter the plan, all that fun stuff. And I thought that was kind of a really cool way to kind of guide what you really want out of the AI, right? So with that said, probably a week ago, GitHub officially announced their spec kit kind of idea, this idea of spec-driven development. We've all heard of TDD and BDD and a bunch of other development types. This is kind of the new cutting edge one. I'm sure it's been around for a while. But the idea there is you actually write your specs first, kind of like your tests first. And you go through and you build effectively this big plan of how you're going to implement stuff, and then you go through it. GitHub has this nice CLI tool. If it loads, it might not load actually. It doesn't load. Just pretend there's a cool CLI tool that has cool commands. But they do effectively the same idea. You're able to plan out what you're trying to build there. So look up that. It's called spec kit, or specify, I think, is the actual CLI thing there. So anyways, so with that said, oh, that sucks. Anyways, pretend there's a cool picture there, and I highlighted that cool thing. Awesome. So this kind of brings me to the next thought of I feel like with AI-assisted tools, there's a lot of YOLO development of dude, let's just see what the AI does, and then all of a sudden you have to fix stuff. But ultimately, we're kind of entering this next phase of YOLO development, which hopefully is less YOLO than the phase before. Going back to kind of this idea of spec-driven development, I've kind of been playing with this a little bit, And like I find myself doing a lot more work up front, which I have kind of some mixed feelings about, but maybe that is the solution long term. So I have to kind of still tinker with that to really form a strong opinion whether this is better, but I think this is better. So take it for what it's worth there. But ultimately, we're trying to get to the point where we're solving lots of coding issues. We're trying to go faster with the help of AI and hopefully not slower. So let's go to the polls here. We have a few more seconds here. So things that help us to move fast. So structure, pizza, a lot of pizza, test, AI, full context, Adderall, perfect. Yeah, all this stuff I'm going to put on my list there. So thanks again for sharing all this stuff. Pretty helpful there. Hopefully a lot of people got some good thoughts there. And kind of just to wrap up here, later today, Danny's going to give a talk on more of the practical tools of getting speed out of AI speed out of tools that are not AI, I should say. So that's at 4:10. So make sure to go to that talk as well. So in summary, just real fast, focus on value, code as a liability, and evolve your skills with AI because at some point it's going to be helpful. So with that said, thank you.